So today I'm going to solve the problem Leetcode scientific climbing stairs, and I'm going to solve this problem via three ways. The first is via recursion plus memoization, which is top down recursion plus memoization. The second is by bottom up DP, which is tabulation, and the third would be bottom up no memory DP. No memory DP. So in the core, they are nothing. These problems are DP problems are nothing, but they are just functional relationship problems. And all we need to do is we need to find that functional relationship and give that to the program, and it will run it for us. So here is how we can do this problem as well. So the first thing we can observe from this problem is that for climbing the stairs we can have two options. Either we can take one step or we can take two steps. So if we take one step, we can directly go to one, and if we want to reach to the second step, we have two options. We can take one step, so that is one way, and the other way is we can directly jump to the second step. So that's another way. So the total number of ways which we are getting is 2. And we can observe that the functional relationship is defined like this for this problem. So it says essentially that f of 1 is 1 if my I is equals to 1, f of 2 is 2, and these are the two states only we need to calculate any more new occurring states. So for f of n, this is nothing but f of n minus 1 plus f of n minus 2 when my I is greater than 2, but it is less than or equals to n. So I'm going to write this exact thing the way it is written over here. So the first way is, let's say I'm writing it via top down db or recursion plus memoization. So we'll start from the function given value. Now our job is to define this f of I. So we'll take one notebook, which is a dictionary, to store any repeated value in the decision tree XYZ. So if I is equals to 1, we'll return 1. If I is equals to 2, we'll return 2. And for any other thing, if we need to compute that into our notebook, and we'll store these value in the notebook, which is a dictionary. We'll say if I is in notebook, then we want to look that value from this notebook, and at the end we want to return this because we have recursively calculated everything, every value that we want to store, and if we have seen that value previously, then we can look that thing from the notebook that we have. So to give you a better example, what I'm suggesting is, so let's say if you want to compute f of 4, so to find f of 4 we need two things. We need f of 3 and we need f of 2. So far we don't have f of 3, but what we have is f of 2 because its initial value is defined. Now for the first time, now we will go again deep in the function and we need to find f2 and f1. But here what is happening is, once we have found that f3 value, now for the future when we need to compute f5, we're going to look up for this f3 value or f4 value directly from this notebook that we have created in the function, and f3 also we have computed what before. So I can show you these two both, like where they are hidden. Go away. Yeah, so let's print out and see if we want to, and how does it look. Print our notebook for, let's say we want to test it for 5. You see, so next time when we need to compute 5, we have already stored 3 and 4 values, and those are getting passed into the function, and essentially that's how we are calculating f3 and f4. Let's submit it and we can check this will get passed. Okay, cool. So now let's say write it via bottom up dp or tabulation method. So one thing we want to do is, like, we want to define our dp array. So we'll define it like this. The dp is, so for the 0 stair we don't have any state defined, so we can just leave it blank, and for the first stair we know that it is going to be 1. Number of ways to reach to one step is 1. Number of ways to reach second step is 2. And that's all we need to calculate any state in the recursive function, or that's the only thing we need to compute when we are calculating the number of ways to reach a stair. So now for I in range, so 3 to n plus 1, we want dp of I is equals to dp of I minus 2 plus dp of I minus 3, I minus 2, and we want to return the last state because that's where our answer is going to be. So this, it looks like this. So initially what we have is, this is our 0 index, So here we are not saving anything. So this is just empty for first two. Now if we need to compute 3, then we do this 2 plus 1, it gets stored 3. Now if you want to find number of ways to reach to the fourth step, that would be previous 2, so 3 plus 2, 4, and so on up till end. So at the end we want to return this n state of the dp, that is dp of n. Let's run it and see how our answer get passed. So this is also getting passed, and this is another faster than. And the third way is bottom up no memory dp, where we need only two variables to store the states, and we already know how what is our state. So we know if n is going to be 1, we want to return that 1, and our number of ways to reach to the first and second stairs are 1 and 2. We just need these two states to compute the remaining states in range 3 to n plus 1. What we want to do is f1, f2. So f1 will have the previous state of f2, and f2 will have the new state by summing up the previous two values. And we want to return f2, and just that's it. Okay. Unexpected indentation, which I don't want, and this I want to return over here. Yep. So let's run it. No, it won't give us mess. So yeah, that's the three ways how we can solve this problem. Okay, thank you.